Good morning, grade 9. How are you today? Today we have a new lesson, chapter 5, lesson 4, rational functions. Our objective today is to transform rational functions by changing the parameters. How we're going to do this? Let's first read about this. A rational function is a function whose rule can be written as a ratio of two polynomials. Again, a rational function is a function whose rule can be written as a ratio of two polynomials. The parent rational function is f of x is equal to 1 over x. So the parent rational function is f of x is equal to 1 over x. Okay, so its graph is called hyperbola. Hyperbola. You remember the parabola? This one for the rational function is called hyperbola. Hyperbola, which has two separate branches. Has two separate branches. So the function is 1 over x. The rational function is 1 over x, and the graph is called hyperbola, and it is two separate branches. Two separate branches, as you can see here. Like logarithmic and exponential functions, rational functions may have asymptotes. The functions f of x is equal to 1 over x has a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0. Okay, the rational function f of x equals 1 over x can be transformed by using methods similar to those used to transform other types of functions. Like, we have a formula here. F of x is equal to a over x minus h plus k. Again, f of x equal a over x minus h plus k, where a is, here we have a, absolute value of a, is vertical stretch or compression factor. A is less than 0, so it is reflection across x-axis. If a is less than 0, so it is reflection across x-axis. What about k? K represents vertical translation. Down for k is less than 0, up for k is greater than 0. Again, k represents vertical translation. It will be down if k is less than 0. It will be up if k is greater than 0. What about h? H represents horizontal translation. Left if h is less than 0, and right if h is greater than 0. Again, h represents horizontal translation. It is left if h is less than 0, which is negative. Right if h is greater than 0, which is positive. And don't forget, as we used to do before, that the sign here is negative. The sign here is negative, so don't forget. Don't forget this one. I think that you remember it now, girls. that when the original sign in the rule is negative, okay, don't forget here to do what? To convert it. So again, if H, the horizontal translation, if H is less than the 0, which is negative, so it will be to the right. When H is greater than, when H is negative, it will be to the left. When H is greater than 0, positive, it will be to the right. So again, I will read it for you. F of x is equal to a x minus h. A represent absolute value of a. Absolute value of a represent vertical stretch or compression factor. If a is less than 0, a is less than 0, which is negative, so it is reflection across x-axis. K represent vertical translation. When K is negative, so it is down. When K is positive, it is up. H represents horizontal translation. When K is negative, so it is left. When H is negative, it is left. When H is positive, it is right. And don't forget that there is here negative sign that will convert everything. Let's watch together a video now.
We've been thinking about rational expressions. Now let's actually do what you know we want to do. Take a look at rational functions. And when I say look, I mean really look. Because of course, just like with any other function, we can look at the graph. And by graphing, we can actually see what rational functions really are like and what's involved in looking at them. All right, so let's take a look at the following function. G of x equals 1 over x plus 5. And what I want us to do is to graph this by first starting off with the parent function, the function y equals 1 over x. So y equals 1 over x, or f of x equals 1 over x, is actually graphed here. This is the graph of 1 over x. So it's not the graph of this. Don't look here. Don't look here. Don't look here. Don't look here. So 1 over x. And you can see it makes some sense. For example, notice that when x equals 0, we can't plug that into the function, right? Because 1 over 0 is undefined. And so when x equals 0, we actually have what's called a vertical asymptote. The function gets really, really close to it, hugs up against it, wants to sort of, kiss it, but can't. This gets closer and closer and closer, but we never actually cross that line. There's also a horizontal asymptote at y equals 0. And that's because as the x's get larger and larger and larger, we see that the y's are getting closer and closer and closer to 0. Okay, so what we see here is a horizontal asymptote, a vertical asymptote, and that is the graph of f of x equals 1 over x. Now, using that as the parent function, let's graph g of x, which equals 1 over x plus 5. Well, you see I'm shifting the x values by taking x and replacing it by x plus 5. The way to think about this, if you're really sort of on top of the game, is to remember we have to write this as a negative. So I write this as x minus negative 5. And that tells me I need to shift to the left 5 units. So I take this picture, and I'm going to move it to the left, shifting the x's 5 units. Here we go. 1.
As you see here, girls, as I told you, the original rule for the denominator is negative h. So the number that I will find here is, I'm going to convert its unit. So if I have x plus 5, since the original rule has a negative sign, so h will be the opposite of the sign that appears here. It is positive 5, so h is equal to negative 5.
2, 3, 4, 5. That, my friend, is the graph of G. Let's think about it, look at it, and see that this makes a little bit of sense, okay? First of all, notice, where is this going to have a vertical asymptote? Well, wherever the denominator is equal to 0, which notice happens at x equals -5. And check it out. When x equals -5, notice that that's where we have our asymptote. So that's great. There's still going to be a horizontal asymptote at y equals 0 because, again, as the x's get larger and larger, x plus 5's still get larger and larger. And so this thing is heading toward 0. So we're heading toward the x-axis. So this actually is the graph of g. Not bad. Let's take a look at another one together. Now, I first want us to start with the parent function of 1 over x. So let me just cue it up here. It's like when you cue up a CD, you know, like it's like I'm a DJ, like I'm a math DJ. I'm a math DJ. I know what I do. I start with 1 over x and see what will happen when I pursue. Okay, I will not quit my day job. All right, g of x equals 1 over x plus 3. Well, now I'm actually adding 3 to sort of everything, so I'm actually increasing the y's by 3. So this is going to be now a shift in the vertical direction 3 units up. So all I'm going to do is take this picture and just raise it 3 units up. Here we go. 1, 2, 3. That's what the graph of this looks like. Let's see if we all agree by just thinking through it a little bit. Well, the first question is vertical asymptote. Well, that's where the denominator equals 0, which you can still see is at x equals 0. And so x equals 0, it's still the y-axis. We have that asymptote. Cool. What about the horizontal asymptote? Well, as the x's get bigger and bigger and bigger, this term is heading towards 0, but then I'm still adding 3. So we should be heading toward a height of 3. And check it out. That's exactly where the new horizontal asymptote is, at 1, 2, 3. So this actually looks like the right picture. You can actually use the parent function of f of x equals 1 over x to actually graph sort of more exotic functions, rational functions. These are all examples of what are called hyperbola. So hyperbolas are beautiful, they're wonderful, and they make you want to sing and rap.
Okay, girls, let's solve together example 1. Transforming rational functions using the graph of f of x is equal to 1 over x as a guide. Describe the transformations and graph each function. G of x is equal to 1 over x minus 3. As we see here, the original rule, x minus h, minus. So since I have here minus 3, so the value of h is the opposite of the value here, negative 3, so h is equal to positive 3. Positive 3. So when h is greater than 3, which is positive, so it is to the right. It is horizontal translation to the right. So it is 3 units right, 3 units to the right. So the hyperbola moved 3 units to the right. So I moved the whole hyperbola 3 units to the right. Okay, from this unit 1 and 1, I will add 3 to the x and 3 to the y, so it will be 4. I move 3 horizontal 3 units to the x because it is moved 3 units to the right, so it is horizontal translation, so I moved 3 units to x only. So 1 plus 3 is 4. And the other point here is -1 and -1, since it is horizontal translation, 3 units to the right. So I added 3 to -1. -1 plus 3 is 2. So the new point will be 2 and -1. Example B, g of x is equal to 1 over x minus 2. Minus 2. The original rule here is positive, so the value will remain the same. So k is when it is less than 0, when it is negative, it will be vertical translation down. So k here is negative. K is -2, so translate f 2 units down. 2 units down. Okay, girls, so when I have a point here, so the whole hyperbola will be translated 2 units down. 2 units down because vertical translation down 2 units. So I have a point here that it's 1 and 1. So since it is vertical translation, vertical, so I will change only the y. So the y here is 1. 1 minus 2 is minus 1. So x will remain the same and y will be changed to minus 1. And the other point is minus 1 and minus 1. So minus 1 and minus 2 is minus 3, negative 3, and x will remain the same. And here I got the new point that the hyperbola will be transferred to. Okay, girls, the next page, page 341, I have here using the graph of f of x is equal to 1 of x as a guide, describe the transformation and graph each function. So I have here 1a, g of x is equal to 1 over x plus 4. So as we said here, the original rule has negative sign. So here I have positive 4. So h here is equal to opposite of the sign. Opposite of the sign. So let me write the answer here. H is equal to negative 4, which means G is translated 4 units left because H has a negative sign. So it is translated 4 units left because it is horizontal translation, and H has a negative value, so G is translated 4 units left. Okay, what about 1b? Okay, 1 over x plus 1 plus 1, so it is vertical translation. G is translated 1 unit up. Why? Because the value of k is positive. So I'm going to write k is equal to 1. So G is translated 1 unit up. Okay, girls, let's continue today the rest of this part. We have rational functions. Let's learn more. For a rational function of the form f of x, a over x minus h plus k, the graph is a hyperbola. There is a vertical asymptote at the line x equal h, and the domain is x, where x is not equal to h, and there is a horizontal asymptote at the line where y is equal to k, and the range is y, where y is not equal to k. So we're going to learn 2 new vocabulary or 2 new words today, which is vertical asymptote and horizontal asymptote. The vertical asymptote is the value of h. Okay, girls, the vertical asymptote is the value of h. And the horizontal asymptote is the value of k. Okay, and when I'm calculating the vertical asymptote, the domain is not equal to the value of h. And when I'm calculating the horizontal asymptote, the range is y is not equal to the value of k. Let's do a quick example here and we will continue tomorrow. Identify the asymptote, domain, and range of the function g of x is equal to 1 over x plus 2 plus 4. So the value of h here is negative 2 and the value of k here is 4. So as we see here, x minus 2. Why? Because the original rule has negative h. So it is x plus 2, so the value of h is negative 2. Okay, so the vertical asymptote is equal to x equal to h. So the vertical asymptote is equal to negative 2. So the domain is equal x not equal to negative 2. Horizontal asymptote y is equal to k. K here is 4. And the range, I'm going to write it in this form, or y is not equal to 4. Okay, girls, let's watch a video here.
All right, let's take a look at sort of a general sense of a particular type of rational function. F of x equals some constant divided by x minus a. All right, let's take a look at sort of a general sense of a particular type of rational function. F of x equals some constant divided by x minus h plus k. And let me say that just looking at this, I can identify a whole bunch of parts, and I want to share them with you. For example, if you want to find the vertical asymptote, the vertical asymptote is going to be where the denominator equals 0. So if I take the denominator, which is x minus h, and set it equal to 0, I see x equals h. So I have a vertical asymptote at x equals h. So I can always get the vertical asymptote pretty easily if the function is written this way. What about the horizontal asymptote? What happens as we go off to the horizon, as the x's get really, really big? Think about it. If x gets really, really huge, that's going to dominate this whole thing, but it's downstairs in the denominator, so that's actually going to 0, and so the y is approaching k. So y equals k is the horizontal asymptote. Notice horizontal asymptotes are always y equals, and vertical asymptotes are always x equals. Then you can talk about the domain and range if you wanted to. It's sort of fun. So the domain would be all the x values, all the real numbers, except wherever you have an asymptote, which in this case would be at h. So all x values except h. And what would be the domain, the range? The range would be all the y values except at the horizontal asymptote, which in this case would be k. So putting these ideas together, we can actually now classify these important objects, and we can actually identify the asymptotes, the domains, the range, whatever you want. Here's an example. Don't memorize like the formulas for these things. Think through them. Think through them. It will be with you forever. So let's first of all figure out the vertical asymptotes. Well, vertical asymptote, that means where, in fact, we are not allowed to be for x. So that's where the denominator equals 0. So x minus 3 equals 0, which means x equals 3. So x equals 3, which does indeed describe a vertical line, x equals 3, is going to be the vertical asymptote. What about the horizontal asymptote? That's going to be a y equals something. What happens is the x's get really, 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 really big. Well, this actually makes this whole thing drop to 0, and I'm left with negative 2. Y equals negative 2. So what about the domain? Those are the allowable x values. Well, all x values such that x doesn't equal the asymptote. Range. All y values such that y doesn't equal the asymptote. So finding domain, finding the range, finding the asymptotes, not a big deal if we can sort of see through the formula and actually see the rational function hidden inside.
Okay, girls, that's enough for today. We're going to continue the second part for this lesson tomorrow, and tomorrow we're going to do the homework. Okay, thank you so much, girls, and see you